Hi all, welcome to i-tutor Academy. In today's session, we will start with the unit 4, that is facilities layout and material handling. It's Mmpc 009. So let's see the objectives of this chapter. After going through this unit, you should be able to appreciate the different type of layout problem, become familiar with the basic type of plan layouts and the factors to be considered for layout design, and comprehend the procedure and designing the layout in the systematic manner, and understand different kind of tools that can be used for the analysis of material flow and activities in a plant, realize how the space is estimated and allocated for different work centers and the facilities, and know the use of computerized techniques for design the layouts, and learn how to evaluate, specify, present and implement a layout, identify the factors that should be considered in the selection of material handling system, become familiar with the different type of material handling equipment used in plant design, and appreciate the integrated approach to layout planning and material handling system design, and the role of automation in plant design. And structure, there is an introduction part and basic type of plan layouts, plant layout factors, layout design procedure, flow and activity analysis, space determination and area allocation, computerized layout planning, evaluation, specification, presentation and implementation, materials handling system, materials handling equipment, summary, keywords and self-assessment exercises, and further reading also. So this is the structure of this unit. And introduction part, importance and function. Facilities layout refers to an optimum arrangement of different facilities including man, machine, equipment, material, etc. Since a layout once implemented cannot be easily changed and cost of such a change are substantial, the facilities layout is strategic decision. A poor layout will result in continuous losses in terms of higher effort for material handling, more scrap and net to rework, poor space utilization, etc. So hence the need to analyze and design a sound plan layout can hardly be overemphasized. It is a crucial function that has to be performed both at the time of initial design of any facility and during its growth, development and diversification. The problem of plan layout should be seen in relation to overall plan design, which include many other functions such as product design, sales planning, selection of the production process, plant size, plant product location, building diversification, etc. And the layout problem occurs because of many development including change in product design, introduction of new product, obsolescence of facilities, changes in demand, market changes, competitive cost reduction, frequent accidents, adoption of new safety standard, decision to build a new plant. Plan layout problem is defined by Moore as follows. Plan layout is a plan of or the act of planning and optimum arrangement of facilities including personnel, operating equipment, storage space, materials handling equipment and all other supporting services, along with the design of the best structure to contain these facilities. Objectives and advantages. Some of the important objectives of a good plan layout are as follows. Overall simplification of production process in terms of equipment utilization, minimization of delays, reducing manufacturing time and better provisions for maintenance. Overall integration of man, material, machinery, supporting activities and any other consideration in a way that result in the best compromise. Minimization of material handling cost by suitably placing the facilities in the best flow sequences. Saving in floor space, effective space utilization and less congestion or confusion, and increased output and reduced inventories in process, better supervision and control, worker convenience, improved morale and worker satisfaction, better working environment, safety of employees and reduce hazards, minimization of waste and higher productivity, avoid unnecessary capital investment, higher flexibility and adaptability to changing conditions. Type of layout problem. The facilities layout problems can be classified according to the type of facility under consideration. Example, manufacturing plants, commercial facilities, that is shop, office, bank, service facilities, hospitals, and residential facilities, house, apartment, cities, township, and recreational facilities. According to the nature of layout problem, it can be categorized into four types as follows, that is planning and completely new facility, expanding or relocating an existing facility, rearrangement of existing layout, minor modification in present layout. Next is flow pattern. According to the principle of flow, the layout plan arranges the work area for each operation or process so as to have an overall smooth flow through the production or service facility. The basic type of flow patterns that are employed in designing the layout and I flow, L flow, U flow, O flow and S flow as shown in figure 1 is here. So this is the I flow, L flow, it's considered the structure, and E flow like that. Okay. So I flow separate receiving and shipping area. L flow is when straight line flow chart to become accommodated. So S flow is when the production line is long and zigzagging on the production floor is required. So like that. Okay. Next is basic type of plan layouts. Depending upon the focus of layout design, there are 5 basic or classical type of layouts. That most of the practical layout are a suitable combination of these basic types to match the requirement of activities and flow. The basic type of layouts are product or line layout, and process or functional layout, cellular or group layout, and D is project or fixed position layout. Product or line layout is this type of layout is developed for product focused system, and in this type of layout only one product or one type of product is produced in a given area. In case of product being assembled, this type of layout is popularly known as an assembly line. The work centers are organized in the sequence of operations. The raw material enters at one end of the line and goes from one operation to another, and rapidly with the minimum of work in process, storage and material handling. So here is one figure is there, that is product or line layout. Okay, please go through your Ignou study material Mmpc 009, that is unit 4. The decision to organize the facilities on a product or line basis is dependent upon a number of factors and has many consequences which should be carefully weighed, and following conditions favor the decision to go for a product focused layout. That is high volume of production for adequate equipment utilization, standardization of product and part interchangeability, reasonably stable product demand, uninterrupted supply of material. And the major problem in designing the product or focused system is to decide the cycle time and the subdivision of work which is properly balanced. Some of the major advantages of this type of layout are reduction in material handling, less work in process, better utilization and specialization of labor, reduced congestion and smooth flow, effective supervision and control like that. And a process or functional layout. This type of layout is developed for process focused system. The processing unit are tendered by function into department on an assumption that, and certain skills and facilities are available in each department. Similar equipments and operations are grouped together. Example, milling, foundry, drilling, plating, heat treatment, etc. And typical process layout is shown in figure 2b. So this is the figure 2b, please refer that, that is about process layout. Okay, and the major advantages of process layout are better machine utilization, higher flexibility, and greater incentives to individual worker, and more continuity of production in unforeseen condition like breakdown, shortage, absenteeism, etc. Cellular or group layout. It is a special type of functional layout in which the facilities are clubbed together into cells. This is suitable for system design to use the concept, principles and approaches of group technology. Such as layout offers the advantages of mass production with high degree of flexibility, and we can employ high degree of automation even if the number of products are more with the flexible requirements. In such a system, the facilities are grouped into cells which are able to perform similar type of functions for a group of products. A typical cellular layout is shown. Figure 2c is here, cellular layout. Okay. Next is job shop layout. It is layout for a very general flexible system that is processing job production. The preparation of such a layout is dependent on the analysis of the possible population of orders and is a relatively complex affair. Project or fixed position layout. So this is a layout for project type and the system in which the major component is kept at a fixed position and all other materials, components, tools, machines and workers etc. are brought and assembly or fabrication is carried out. This type of layout is now not used very commonly as the machines required for manufacturing work are big and complicated. The fixed position layout is used only when it is difficult to move the big and major component and fabrication is to be carried out. A typical example is production of ships. Some of the major advantages of fixed position layout are as follows. The handling requirement for major unit are minimized, flexible with reference to the changes in product design, high adaptability to the variety of product and intermittent demand. The responsibility for quality can be pinpointed. The capital investment is minimum. So here is figure 2 is here, fixed position layout. And the fixed position layout is used ideally for a project situation for one product of a different type. As the quantity increases, the production operations can be broken down into different work centers and the material can be allowed to move rather than the machine, and the process layout is preferred. With further increase in volume, with the mass production, the advantage of production line can be better derived and a product layout is desirable. The break-even analysis comprising the production volume of the three basic layouts or product, process and fixed position layout is shown in figure 3. This is figure 3, break-even point analysis of basic type of layouts. This is the figure 3. Next is plan layout factors. What are the factors for plan layout? The design of any layout is governed by a number of factors and the best layout is the one that optimizes all the factors. As discussed by Mutter, the factors influencing any layout are categorized into following 8 groups. That is the material factors, the man factor, machinery factor, movement factor, waiting factor, service factor and the building factor and change factor. So these are the different factor or categories for the factors influencing the layout. Okay. So next is layout design procedures. What are the procedures for layout design? So the overall layout design procedures can be considered to be composed of 4 phases. Phase 1, that is on location. Phase 2 is general overall layout. Phase 3 is detailed layout. Phase 4 is installation. And some important guidelines that help in layout design are plan from whole to detail, and first plan the ideal and then move to practical aspect, and material requirement should be central to the planning of process and machinery. Modify the process and machinery by different factors to plan the layout. And though there is always an overlap in the different phases of layout design, the major steps that have to be followed in layout design are outlined as follows. That is statement of the problem in terms of its objective, scope and factors to be considered, and collection of basic data on sales forecast, production volume, production schedules and part list, operation to be performed, work measurement, existing layout and building drawing etc. And analysis of data and its presentation in the form of various charts, designing the production plan process etc. So follow up is there. Please go through your study materials. And here is one figure about systematic layout planning procedure. Please go through it. There is an input and activities, then it come to the flow of material and activity relationship, then there is a relationship diagram, Then it come to space relation diagram, and there parallelly space requirement is there, space available is there, and then after that develop layout alternatives, and then evaluation is there. This is the basic of system layout planning procedure. And the next is flow and activity analysis. What is flow and activity analysis? There is data collection. The development of any layout is dependent on the quality and quantity of facts that we have about the various factors influencing it. The data collection phase is not a one-time effort but an ongoing function. The data for overall plan is to be collected at the initial stages, whereas the data for detailed layout may be obtained at a later stage. And the fact have to be obtained regarding various materials and processes, the flow routing, and as you can see space requirement and different activities and relationships. The information required about the material and process is listed table 1. So table 1 is here. Product specification, product volume, component parts. These are the table about information required about the material and processes. Process chart. What is process chart? There are many type of process chart that can be developed. The most commonly used one are operation process chart and flow process chart. Operation process chart, this is a graphical representation that describes the different operations and inspections is a sequential manner including information regarding time and location. And flow of process chart, the arrangement of facilities in a production process govern the flow of product and vice versa. Flow diagram, it is a sketch of the layout which shows the location of all activities appearing on a flow process chart. The path of movement of material or man is traced on a flow chart diagram, and the different activities are given by process chart symbols with a number. This gives an idea about the overall flow through the plant in a pictorial manner. And any backtracking or crisis crossing of the flow can be pinpointed, and the layout engineer can redesigning the layout for a smoother flow by minimizing these wasteful flows. And travel chart, it is also known as from to chart. Okay, that is travel chart. So this chart is helpful in analyzing the overall material flow. It indicates the distance and number of move between different pair of departments taken as origin and destination. So this is about a travel chart. Okay, and here is the diagram representative for same. So please go through it. Okay, and some of the important advantage and uses of travel chart. It helps in analyzing the material movement, it aids in determining activity location, it alternates flow pattern and layout can be compared. It shows relationship of different activities in terms of volume of movement, and it depicts quantitative relationships which can be used for computerized analysis and QR application. Next is REL chart, REL. Okay, this is known as relationship chart, which indicate the relationship between pair of department in terms of closeness depending upon the activities of the department as a absolute essential, as absolutely essential, essential, important, ordinary, unimportant, undesirable, like that. A typical relationship chart is here. This is the relationship chart. Okay, AEIOUX. Okay, so here is also steps 1, step 2 and step 3 is there, an example also here, please go through it. Okay, application of quantitative technique use. The technique use of operation research can be applied to quantitatively analyze the layout problem, particularly in terms of material flow. Some of the important technical the technique that have been applied by different researchers in the field of layout planning as linear programming, transportation algorithm, transshipment problem, assignment problem, traveling salesman problem, dynamic programming, queuing theory, simulation, etc. And linear programming is used when there is a linear objective function which is to be maximized or minimized subject to certain linear constraints, and in the layout design the objective is to minimize the material handling. Transportation and assignment problem are special cases of linear programming. And further, to meet the multiple objectives of layout planning, attempts have also been made to apply goal programming as a technique of multi-criteria decision making, and these operations research technique are discussed in the other courses. Okay, so this is about today's section. Next session we will discuss on next video. And for more MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.